Hello guys, welcome back to my channel. Please remember to like and subscribe. Now today we'll be talking about reflection. And of course we all like the idea of reflection because we like to stand in front of mirrors and look at ourselves. But reflection is an integral part of our daily lives. Um, if you look at how a telescope works, that utilizes the concept of reflection, the microscope and so on. There are so many different ways we use it, but the most common way is actually us looking at ourselves in front of a mirror. All right. Now for today's class, we're gonna be doing a physical activity, but we're gonna require the use of a plane mirror. A plane mirror is a mirror that doesn't distort your shape. Now for our investigation, you're gonna stand at a selected distance away from your mirror. You're gonna look at your image in the mirror, and then you're gonna walk backwards. Now, what you're gonna do is to write down what happens to your image when you walk backwards. So you're gonna walk further away from the mirror, and then you're gonna walk towards the mirror, and you're gonna describe the action of your image inside of the mirror. That is the first part of the activity. You can actually pause the video and do that part. For the second part, I want you to stand in front of the mirror again, and I want you to move your right hand. You're gonna write a small synopsis of what happens inside of the mirror, what happens with your image. You're also gonna move your left hand and say what happens as well. Now at different distances, we also want you to observe your size. What happens to your size when you look inside of the mirror? Is there any changes? You're going to record that information as well. Now, what you're going to do is to simulate the properties of reflection. Write down what you think the properties of reflection are, and then we're going to discuss them. Let us now investigate the properties that you probably would have found out. So here we have a dog, and the dog is looking inside of the mirror. I'm using my y-axis here as my mirror. Now what happens when a dog looks inside of that mirror? The dog will actually see an image, and let us see what happens here. There's the image of a dog. Now our first activity that we gave you to do was for you to stand at a distance away from your mirror and to move backwards and forwards. So let us see what happens if a dog moves backwards. Notice what is happening to the image. The image seems to be moving backwards as well. Now let us stop this at some point. Now let us count the distance that this dog is away from the image. So we have 1, 2, 3, 4 units. Now let us look at the mirror again, which is the y-axis, and let us look at the image. 1, 2, 3, 4. So it would appear as if the dog and its image is the same distance away from the mirror. So it's almost symmetrical about the mirror line, or it's actually symmetrical about the mirror line. So if I were to bend this on the mirror here, then the image would overlap on the object. Now let us move upwards and see what happens. So you see, when we move upwards, the image seems to move upwards by the same amount. Let us move downwards. A similar concept happens. If we move forward, if we move towards the mirror, then the image also appears to move towards the mirror as well. And if we move backwards, as we had said initially, the same thing happens with the image. Now, when I move towards the mirror and away from the mirror, I do observe that the dog, the object, which is on the left, and the image, which is on the right, those seem to be the same size. So we can agree that there's no change in size here. The size is the same. Alright? We can also say that the shape is also the same. But there's something that has happened here. So initially, my object is looking to the right, but my image is looking to the left. Now, this is a very important concept that is going to come out here, and the term used for this is lateral inversion. So it will appear as if your left side seems to be your right side and your right side seems to be your left side. Because when you move your left hand in the mirror, what actually seems to move is actually your right hand. When you move your right hand, your left hand also appears to move. And that effect is what is known as lateral inversion. So once an image undergoes a reflection, it is going to be laterally inverted. Now, we had said initially that we're using the y-axis as the mirror line. Now, let us observe the coordinates because my mirror is my y-axis here. Let us observe what happens with the image when I move around. So I move upward, I move downward, I move forward, and I move backward. If you look at the y-axis, you notice that the object and the image always seem to be in the same position where the y-axis is concerned. In other words, they seem to have the same y-coordinates at all points. So it doesn't matter where I move, the y-coordinates seem to remain constant. Alright, so it will appear as if when I reflect in the y-axis, y remains constant, but x changes because my object is on the left. If you look at the coordinates are negative. My image is on the right. If you look at the coordinates, they are positive. But for instance, if I look here at the tip where the dog is at -4 on the x-axis, when I look on the right, on the positive x-axis, I notice it is at +4. Alright? So that is telling me that the image and the object are equidistant from the mirror line. Now let us look at what happens if I were to reflect this in the x-axis. So let me go over to the right where I have my image there, and I'm going to reflect it in the y-axis. Sorry, in the x-axis. Now this time, because my mirror is the x-axis, look at my x values, 4, 4. So that you notice that the x values here are constant because my mirror line is actually the x-axis. Now if you look at the y values, looking at the image, you notice the y values are positive here, and down here they are negative. They're actually the same values, but they're in the negative of each other. So when I reflect it in the y-axis, the y values remain the same. When I reflect in the x-axis, the x values remain the same, but the y values become negative. Very important observation here. So when my mirror line is the x-axis, and when my mirror line is the y-axis. Now to carry out a reflection, the only thing we practically need is the object and the mirror line. Now I'm looking here now at a reflection in the y-axis. So let us look at my object. On the far left here, we have the coordinates of this object, which is A, -1, 1, B, -8, 1, and C is -4, 5. So those are the coordinates of my object. Bear in mind that my mirror, in this case, which is what I'm calling my mirror line, is the y-axis. Alright? So let us see what happens when this is reflected in the y-axis. So here I'm going to be using the GeoGebra software. Alright, so look at A. Bear in mind that A had a coordinate -1, 1. Now look at A prime, which is at 1, 1. If you look at B, B was -8, 1. And if you look at B prime, B is 8, 1. If you look at C, bear in mind that C was -4, 5. And if you look at C prime, it's at 4, +5. Now, as we agreed in the previous section that whenever you reflect something in the y-axis, the y-coordinates remain the same, and you can see that all the y-coordinates are the same. The x-coordinate though would have become negative. So where you had A and the x-coordinate being -1, A prime, the x-coordinate is +1. B, the x-coordinate was -8, and now look at B prime, the x-coordinate is +8. So if I give you the object and I give you the mirror line, which in this case is the y-axis, how can you easily get the image? We simply know that the y values will remain the same, but the x coordinates will become negative. Right? So that is one shortcut you can actually use to draw the image. We negate all x coordinates and y coordinates remain the same. Otherwise, we could also use a counting method. Look at where A is. A is 1 unit away from the mirror line. So A prime must be 1 unit away from the mirror line in the opposite direction. Look at B prime. Let us count how far B, well, let us count how far B is first away from the mirror line. So we had 1, 2, 3, 4, 5, 6, 7, 8. So B prime must also be 8 units away from the mirror line. Let us check that. 1, 2, 3, 4, 5, 6, 7, 8. 8 units away in the opposite direction. So we can use a counting method, or we can simply keep the y coordinate constant and negate the x coordinate. That is one way of looking at it. We're going to use the same object ABC, but this time we're looking at a reflection in the x-axis. Now, the x-axis also has a special name. We call it y equals 0 line. Just like how we can call the y-axis x equals 0. So if I ask you to carry out a reflection in the line y equals 0, then you know that I'm talking about the x-axis as well. Let us see what happens with the coordinates this time when I reflect in the x-axis, alright, or in the line y equal to 0. So once again, we're in GeoGebra. So there we go. Notice we have lateral inversion. Similarly, the image and the object are the same size, so that is important there. The size is preserved. Now, let us look at, because we're reflecting in the x-axis this time, let us look at the x-coordinates. As you can see, if I were to bend this, or if I were to bend the Cartesian plane about the x-axis, then these two would actually overlap, which means that the x-coordinates would have remained the same, but the y-coordinates would have changed. Now let us look at A. A has the coordinate negative 1, 1, but look at A prime. It is negative 1, negative 1. So the x-coordinate remained the same, but the y-coordinate was negated. Look at B. B is at negative 8, 1, but B prime is at negative 8, negative 1. So a similar concept is applied. So whenever I reflect in the x-axis, the x-coordinates will remain constant, but the y-coordinate becomes negative. You can also use the distance, because if you were to count the distance away that the object is from the image, is from the mirror line, sorry, it will be the same thing for the image from the mirror line. So let us see, look at A. A is 1 unit away from my mirror line, and A prime is also 1 unit away from my mirror line. And you can do it for A, B, and C, and you'll actually see a similar concept. So once again, when I reflect this image in the x-axis, the x-coordinates remain the same, but the y-coordinates are negated. And we can count the distance as well if we are given the object and we need to find the coordinates of the image on the Cartesian plane. We don't always have to reflect in the axis. So I don't always have to reflect in the x-axis or the y-axis. I can create any general line and carry out a reflection in that line. Now let us say I want to look at a reflection in the line x equal negative 1. So the first thing I need to do is to draw that line. So let us draw the line x equal negative 1. Now, of course, we know that the line x equal negative 1 will actually be a vertical line passing through negative 1. So at every point on that line, x would be equal to negative 1. So x equal negative 1. Alright, so that is my line here. Now, look at my object. You can see the coordinates of my object on the left here. A negative 3, 1, B negative 10, 1, and C negative 6, 5. Now, what happens when I reflect in this line x equal negative 1? Now, let's see. So, here my coordinate A was negative 3, 1, but A prime is 1, 1. Now, of course, we're seeing a key difference here. What is the major difference that I have in this scenario? Because I'm not reflecting in the standard axis, we won't have a constant just remain the same and then another one just change just like that. Alright, there's a difference in this case because I'm using a random line. So for this particular line that I would have created x equal negative 1, what we can simply do is just count off the coordinates. Look at where A is. A is 1, 2 units away from my mirror line. So to get A prime, I count 2 units in the opposite direction. So I'm at the mirror line, so I'm going to count 1, 2. Alright, and I put A prime there. So you simply just put a point there. Use a similar concept for B. B is 1, 2, 3, 4, 5, 6, 7, 8, 9 units away from the mirror line. So likewise, when I'm trying to find B prime, I'm going to count 9 units away from the mirror line in the opposite direction. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course, you apply a similar concept to C. C is 1, 2, 3, 4, 5 units away from the mirror line. So C prime will also be 5 units away from the mirror line.